Hello, I am David W. Parker. This is Programming Today I Learned 3D Math Series, episode 26. Today we're going to be looking at Euler angles, yes, that's Euler, not Euler, and how they play into orientation and angular displacement. So as you'll recall from previous episode, you can use matrices, which is 9 different numbers to display. With Euler angles, we only need 3, about 3 mutually perpendicular axes. Well, in what axes in what order? Normally we're going to use cardinal axes, and we're going to use heading, pitch, bank convention for the order. And so what does that mean? We're going to have 3 angles: the heading angle, a pitch angle, and a bank angle. Since we're using the left-hand system, plus x is right, plus y is up, and plus z is forward. So heading is the first one. It's going to rotate about the y-axis, so that's up and down. So first you're going to rotate around in a circle, circular fashion, and then pitch is next. It's going to rotate about the x-axis. So if you think of a plane that is an airplane that is facing you with the nose coming towards you at z, it would basically be rotating around a general sideways direction with that plane, basically with one wing or another wing going up or down for each wings. And bank is last, and that's going to rotate around the z-axis, and that, if you think about that airplane again, the nose will be tipping upwards or tipping downwards. And so the ordering is always going to be in heading first, then pitch, then the bank, when we're rotating from the object space to inertial space. And inertial space to object space. And when we're going to rotate from object space to the inertial space, then it's going to do the backwards. So we're going to do pitch, or bank, pitch, then heading. And this is very similar. You may have heard of roll, pitch, yaw, where the bank is synonymous with the roll and yaw is pseudo-synonymous with heading in the reverse order. A few conventions: we can use any perpendicular axes. We don't have to use the cardinal ones, but we do because it's convenient. It isn't necessary to define left or right hand rules, but you should know what you're doing. And the rotation can be in any order, but the order does matter. And the heading, pitch, bank convention is just the most common and normally the most useful, so we'll end up sticking with that. Some advantages to Euler angles is they're easy for humans to understand. When we think about how things are oriented, we'll think in terms of degrees and angles. It's very easy for us to think about. When orientations need to be displayed and input by a user or something like that, you'll generally want to have them put it in as an angle. It's also a third the size of matrices, so it can save on memory a lot. And any 3 numbers are valid. It's never going to be incorrect, versus, as we saw in the last episode, matrices can often have incorrect values. But that's not without a lot of disadvantages too. They're not unique for any orientation. So there's an infinite number of Euler angle triplets that can express the same orientation. So for example, if you had 45, 0, 0 as your 3 angles, and then you also had 405, 0, 0, that's the same because we added 360 degrees, but it still ends up being ultimately the same orientation. And each angle isn't independent of the other. So pitching down 135 degrees is the exact same as heading 180, pitching down 45, and then banking 180. So to solve this, what we'll normally do is to restrict the range of angles for heading and bank to plus or minus 180 and pitch to plus or minus 90. Also, a famous aliasing problem is the Gimbal lock. So if we pitch an angle to plus or minus 90, then from then on we can only rotate about the vertical axis. The first and third rotations are then rotating about the same axis. So that's an issue that can come out. And fix this, all rotations about the vertical axis when we're in a gimbal lock are always assigned to the heading. So that's a big issue too. Finally, interpolation is another issue. If we're going to interpolate between 2 different angles, we have a naive solution, which is the change in theta is going to be theta 1 minus theta prime, or 1 minus initial, and so the change would just be the initial plus the time of that and the change. But you think about it, if we have something oriented around to 720 and the next one is 25 degrees, should only be a nice 25 degree change, but because we're spinning around to remove the 720, we're going to go multiple times in the wrong direction before getting to that correct orientation. And that's if we're outside of the canonical Euler angles that we explained right here. Now let's say we're within that. So we have orientation A is negative 160 degrees and orientation B is positive 160 degrees. So they're only 40 degrees apart, but again, because of the way rotation works, you're going to end up spinning around the wrong way again and still doing way too much rotation. So the solution for this one is we're going to wrap around x, and so we're going to have x minus 360 times the floor, that's what this symbol means if you don't recall, of the x plus 180 over 360. And so then we can define what that change of theta will be is the wrap of the angle change in that. So that's it for this episode. That's all we're going to have for Euler angles. We're going to jump right into quaternions next, and we'll have a lot of episodes about those. So if you like what you saw today, go ahead and give us a subscription and a like, share on social media if you will. Go to ProgrammingTIL.com and sign up for our newsletter. Have a great one. Thanks.